Welcome to Ask and Learn.
So for this problem, it asks, it considers two gases that are separated in a box. One has 500 molecules of nitrogen. One side has 100 molecules of oxygen. And then the partition gets a hole, and now the particles can kind of migrate back and forth. How many particles are going to be found on each side? Well, if they're allowed to migrate, there's no reason one particle would be found on one particular side. So you're going to have 250 nitrogen on each, and then you're going to have 100 oxygen. Oh, my zeros are funny. Sorry about that. On each side. Okay, and then for part B, what's the change in entropy? So the change in entropy is going to be the change in entropy for either gas. And so for the nitrogen, so there's actually a formula derived in the book that in general, if you double the volume, and it's example 20.11, that it's going to be this, and KB ln 2 plus N oxygen KB ln 2, and so that's going to be 6. So there's 500 of the nitrogen. So I'm just going to break convention and just write the actual number right under so I can save a line of algebra. It's going to be 600 KB times the ln of 2. And if you put that into a calculator, perhaps you will get, give me 1 second, 5.74 times 10 to the minus 21 joules per Kelvin. And what's the probability of the particles staying on either side of the box? Well, you'd have the probability, or finding the system in a state where half of each set of particles is on either side of the box. So you'd have to, so the probability of an individual particle being on either side is 1/2. So you'd have to have that be true 500 times for all the nitrogens, and then 100 times for all the oxygen. So whatever, let's see, so if you stick that into a calculator, what do you get? 2.4 times 10 to the minus 81. So as you would expect, it's very unlikely that the particles will just stay where they are or end up being such that they're occupying only 1/2 of the box. I'll put a little note to summarize that. Small.